Right, good morning, learners. This lesson is recorded in the morning of the 20th today.
Today is 27, I think.
This is the 27th of May. We record a lesson regarding the 2023 MSc mock exams from Michiru Secondary Schools. Michiru Secondary Schools is one of the renowned schools in Malawi, particularly in Blantyre. It's one of the best schools in Malawi. There are many good schools in Malawi. One of the best is Michiru Secondary Schools. In as far as local syllabus curriculum is concerned. So welcome. This is 2023, quite old paper. It's 3 years old, 3 years ago. This being 2026, it means we are looking at a paper which was written 3 years ago. Welcome, learners. My name is Mr. Paul Chirola once again. If you are watching this video on our YouTube channel, consider subscribing to the channel. It's important that you subscribe so that every time we upload a new video lesson, you are notified. You are notified, you get a notification of our presently posted lesson. So as we revise the paper, we are going to dwell a lot on key topics because this paper, as you see, is 150 marks, which means that it is covering a diverse range of topics. So as we go through the paper, we are going to explore the important concepts. We believe that if you master the concepts, the terms used in chemistry, you shouldn't have to struggle to pass the MSc exams. Our goal is to have exam success. We emphasize on understanding the key concepts. As a school online, we believe that revision today will lead to success tomorrow. Welcome, learners. Without wasting your Let's look at question number 1. Define an acid in terms of the Bronsted-Lowry theory. An acid or a base are defined in different ways. Like in junior certificate level, you defined an acid as any substance that can release hydrogen ions in solution. That's quite okay. That's called Arrhenius equation. Arrhenius theory of an acid. But the question is not asking for Arrhenius definition of an acid, it's asking for Bronsted-Lowry theory. Definition according to the Bronsted-Lowry theory, the definition of an acid is simply a substance that donates. To donate means to give. That donates a proton A proton is just a hydrogen ion to another substance during a chemical reaction. This is the definition according to Bronsted-Lowell theory. Unlike the Arrhenius theory, Arrhenius says that an acid is any substance that can release hydrogen ions in water in solution. And it goes on to define a base as a substance that releases hydroxide ions in solution. But the question is not asking for Arrhenius definition. It's asking for Bronsted-Lowell theory. It says the definition of an acid is a substance that can donate. To donate means to give. For example, if someone is giving you 1,000 kwacha, it means that person is donating it to you 1,000 kwacha. But here we are looking at an acid. What is a substance? What is an acid? It's a substance that donates, that gives a proton, which is hydrogen ion, written as H with plus on top, to another substance when during a chemical reaction. I should take advantage of this to say that the examiner in the future will ask you to define a base in terms of the Bronsted-Lowell theory. If definition of a base in terms of Bronsted-Lowell theory is that a base is a substance that accepts. The opposite of donate is to accept. It accepts what? A proton, which is hydrogen ion, during a chemical reaction. I thought I should say that. Number 1B. We are going to look at this one. You are provided with 3 solutions: iron 3 sulfate, aluminium sulfate, copper sulfate, and ammonia solution. And then there's this instruction: to each of the solutions add 5 drops of ammonia solution and record the observations. In my opinion as the teacher, this question seems or sounds like it's a practical question requiring students or candidates to do something. There's a direct command here which says add 5 drops, which means that the question is instructing students to do something, and this must be practical. But let's ignore the fact that this is a practical question. Let's take this as a question that has just come normally based on what students already had done. So we assume that students had done this practical before, and they already have a preconception or preconceived ideas what the results could be. So adding a few drops of ammonia solution to iron sulfate would produce what is called a precipitate. That precipitate is going to look reddish brown in color. Remember that a precipitate is a solid substance which is formed when 2 solutions are mixed. So once again, adding a few drops of ammonia solution to iron sulfate to produce a reddish brown precipitate. Okay, this precipitate is a solid form, and it's colored reddish. It's reddish brown. If you keep adding more ammonium sulfate, excess means extra. The word excess means extra. So adding extra drops of ammonia would really maintain the same precipitate, but it will not dissolve. The precipitate remains insoluble. Insoluble means it remains undissolved. All right, that was sulfate, aluminum sulfate. When you add a few drops of ammonia, and when you add excess drops of ammonia, let's move on to aluminum sulfate. Aluminum sulfate When you add a few drops of ammonia solution to it, you are going to form a white precipitate. So a white precipitate is formed which remains insoluble, meaning that it does not dissolve when you keep adding some drops of ammonia solution. Once again, my name is Mr. Pochilola, your teacher on this platform. Remember, on this platform, we offer the sciences, namely physics, chemistry, biology, agriculture, and mathematics. We are looking at a paper which was written 3 years ago by our friends at Michiru Secondary School. What will happen if you add a few drops of aluminium sulfate to copper sulfate? What will happen? You are going to form a precipitate which is blue in color, but if you add extra ammonia to it, the solution will turn very deep blue. So the precipitate dissolves, forming a deep blue solution. Once again, I want to point out that this question is supposed to be a practical question where students are doing this practically, but I think the examiner is assuming that this practical is done, so these are the results. So you must just have to know that these are the results you will obtain if you are testing for sulfate ions, iron ions, aluminum ions, and copper ions in sulfate solution. Take note, my name is Mr. Paul Shirora, your teacher and your partner in progress. Welcome. C. Numbers. Question 1C. Question 1C is asking us to state two importance of the water cycle. The water cycle is also called the hydrological cycle. All right, which we define as the natural circulation of water between the earth and the atmosphere during the hydrological cycle or the water cycle. Water evaporates from the earth due to heat from the sun, from the lakes like Lake Malawi, Shire River, Rukuru River. I'm referring to these examples because they are within the Malawian context, Indian Ocean, other places, even plants. Remember that water from the sea, from the oceans, from the lakes is heated by the heat from the sun, and it causes the water to evaporate. It goes up high into the atmosphere. Right there, it meets very low temperatures whereby the vapor turns into liquid, which is called precipitation, and then that precipitation, which is rainwater and hail water, will fall to the ground. So what's the importance of that? There are quite a number of importances. One of them is that it provides fresh water for plants, animals, and humans. You have heard the expression that says that water is life. So the water cycle provides water to plants for growth, animals to carry out different processes, as well as humans. Without water, we cannot survive. So that's one importance of the hydrological cycle. It maintains the water balance in the universe. But other than that, it also regulates temperature. Remember that water is a good coolant, meaning that it cools the earth when rain falls, thereby maintaining suitable temperatures for humans, animals, and plants. But it also helps to regulate climate. Climate is the change in the weather patterns over long temperatures. Beg your pardon. over long temperatures. So things like weather, rainwater, humidity, wind direction, and many others, atmospheric pressure, are regulated by the water cycle. Welcome to number 2. My name is Mr. Pochirola once again. We are doing this to help you prepare for your MSCE exams. Question number 2. Figure 1, this is the first figure that we have made so far. Figure 1 shows electrolysis of dilute copper sulfate using carbon electrodes. I've always mentioned this to my students that when a question comes, you must look at the key words, the key terms in the question. One of the key terms is electrolysis. Electrolysis is the splitting of a substance, like in this case copper sulfate, into its ions by use of electricity, the electricity coming from a battery. You must know this because the examiners are already assuming that you know what electrolysis is. Another one is carbon electrodes. Carbon electrodes by nature are inert, meaning that they don't react with the solution in which they are dipped. So in this case, the carbon electrodes, cathode and the anode, won't react with the copper sulfate solution. They are inert. The word we use is inert. Unlike if you dip copper metal, if these were made of metal, copper metal, they would begin to react with copper sulfate, and the results that would be obtained were going to be different. Question 2, part 1, name 2 anions present in the solution. So anions are basically negative ions. Ions carrying negative charge on them are called anions. So when you split copper sulfate in solution, you are going to have 2 anions. You will have sulfate ions written as the SO4 and the 2 minus. This is called sulfate ion from copper sulfate. This is a sulfate ion. But because water is also involved, this is a dilute solution. Because it is a dilute solution, there's also going to be hydroxide ions from water. It's OH, but don't forget to put a minus here. These are called anions. The word anion means negative ions. Okay, maybe before we proceed, it is important to mention that there are also going to be cations. The cations are the positive ions. In this case, we are going to have Cu2 plus from the copper sulfate and the hydrogen. Remember, hydrogen is H, hydrogen ion is plus. So these are the cations. Our cations, and these ones over here are our anions, negative ions. Positive ions are going to be the copper ions, Cu2 plus, and the hydrogen ions. The anions will be a sulfate ion, which is SO4, 2 minus, and the hydroxide ions, the OH minus. The question is saying name 2 anions present in the solution. It's these ones, the sulfate ion and the hydroxide ions. All right, so you need to say the sulfate ions SO42 minus and the hydroxide ions OH minus. You get 2 marks for doing that, 1 mark for each. So you have 1 mark and plus another mark, that's 2 marks. Explain using half equations what happens to the cathode. Practically, what you do see in this setup is that the copper ions are going to be reduced, meaning that they'll gain electrons to form copper metal atoms here. You'd actually see some pink, red, brown color of substance forming around here. All right, it shows that copper metal is forming there. And copper metal is formed when the copper ions, these ones, obtain 2 electrons, gain 2 electrons, they will be reduced to form atoms. And those will coat the metal over here, and you'll be able practically to see that a metal is forming. Copper is reddish in nature, so you'll be able to see that. So according to the question, you need to indicate that pink, brown, or red, you can also say red copper metal deposits on the cathode. Remember the cathode, this is the cathode connected to the negative terminal of the battery, this one. The switch being closed, you will see a metal forming on this one. All right, so by saying pink, brown, copper metal deposits on the cathode, you get 1 mark. And he goes on to say we must write down the half equation. The half equation will involve the copper ions which are present in the solution gaining the 2 electrons to form copper metal solid. So the copper metal solid is going to deposit there. You should be able to see the copper metal depositing there. All right. So 1 mark for this saying this statement, another mark for writing the half equation correctly. State any one factor that affects preferential discharge during electrolysis. Preferential discharge refers to the depositing or the gaining and the losing of electrons of the ions that are present in a solution there. All right, whether it's gaining or losing electrons, it will lead to formation of new substance at the electrodes. If a substance is being reduced, listen carefully, it's being reduced, meaning it's gaining electrons, then the atoms of that are going to form on the cathode. If the substance is being reduced, oxidized, it means that substance will have to lose electrons, and its atoms will form on the other electrode. So there are factors that govern that. One of the factors that affect preferential discharge is the position of the ion in the electrochemical series. Remember, electrochemical series is a list of the ions in order of whether increasing ease of gain of electrons, which is reduction, or according to the ease of which the ions are oxidized, which is loss of electrons. That's called electrochemical series. So one of the factors affecting that is the position of the ion in the electrochemical series. The ions which are below, which are at the bottom or lower in the electrochemical series, have the greater potential to be deposited or to be preferentially discharged, either to gain electrons or to lose electrons. That's why I would come back to this. You see copper ions and the hydrogen ions are present in the same solution. Okay, despite both of them being positive, it is copper ions that are oxidized, rather reduced, to form copper atoms there. Because copper compared to hydrogen is lower, is at the bottom in the electrochemical series. So check which one is lower, hydrogen or copper in the electrochemical series. All right, so I was asking my colleague here, electrochemical series, All right, I was asking you to check just to verify which one is lower, copper ions, copper or hydrogen. So we are saying copper is lower in the electrochemical series than hydrogen. Therefore, it is copper that is going to be discharged here, preferentially discharged. So what position? So ions lower in the electrochemical series are potentially discharged, meaning that copper here is lower. I'm just giving this situation as an example, which is lower. CE. Well done, learners. Another factor is the concentration of the ions in the electrolyte. So the higher the concentration of the particular ion in the electrochemical series, the more preferentially discharged that ion is going to be. Which one is lower? Hydrogen or copper? All right, so in this case, it means that there are more copper ions than hydrogen ions. Therefore, copper ions are the ones to be discharged here. Another factor is nature of electrodes. I beg your pardon. This is supposed to be electrodes, not electrolytes. Nature of electrode.
Copper is lower than hydrogen in the electrochemical series. Order from higher to lower.
Nature of electrodes. What are you saying? Copper is lower, right? Yeah, so if copper is lower, once again, we go back to the question. I wanted to emphasize that position of the ion is very important. So ions that are lower in the series are going to be preferentially discharged. Take note of that. So in this case, is copper ions. Ask it which one will be discharged. Which one will be discharged?
Okay.
Here. Wait. But yeah, so which one will be discharged? Ask it. So nature of electrodes. Here we have carbon electrodes. Carbon electrodes, like I mentioned earlier on, you will appreciate that they don't react with the solution in which one will be this? Carbon electrodes are innate, naturally, meaning they don't react anyhow with the solution in which they are dissolved, so nature. But if suppose we put copper electrodes, copper metal, it means the copper metal will begin to react with the copper sulfate. Therefore, Therefore, would have more ions than what we just stated because they proceed. Don't do what you want to do. I got it. I got the idea.
Okay.
Nature of electrodes. If you put copper metal here instead of the carbon electrodes, we'll get different ions. Therefore, that would also affect the preferential discharge. So in this case is Y. Y has formed the two spots, this one here and this one. Therefore, Y is 4 ingredients. So the answer is Y. Remember, this is X. This must be Y. Number 3, calculate the retention factor of relative fraction of the sample X. Relative flow value is defined as the distance traveled by sample X divided by distance traveled by the solvent. So the distance traveled by sample X is 3 centimeters. That traveled by the solvent is 4. So dividing the two is 7.5. C. State 3 factors which must be met when conducting an experiment to electroplate a silver spoon with copper sulfate using electrolysis method. So we are coating a silver spoon with copper metal. In order to do that, we must meet some conditions. One condition is that the anode must be made of pure copper. Another condition is that the cathode should be the object to be electroplated. And lastly, the electrolyte, which is the solution, must contain ions of the plating metal, in this copper sulfate. Just to review this, so we have 3 marks here. All right, it means each point is 3 marks. So solving for x, it means we take the minus 6 to this side. It will be minus 6 plus 6 plus minus 1, which is plus 6. So the oxidation state of chlorine in this case is simply minus 5. Number B, part B, 3B, define the term mole. The term mole is defined as the amount of substance that contains exactly 6.022 or 23 times 10 to the power 23. Sorry, guys. So this is 6.023 multiplied by 10 to the power 23. Particles, this is quite a huge number of particles. So that's what a mole is. So a mole is defined as the amount of substance that contains exactly 6.023 times 10 to the power 23. You forgive me for this number. It looks so quad. Particles. In case you want to know how big that number is, 6.023 times 10 to the power 23 means 6. What it means, I'm doing this for my friends who may not have understood the meaning of this number. All right, 6.023 times 10 to the power 23. It means 6, 0, 2, 3. And you add zeros, a lot of the zeros. Welcome, learners. I'm trying to explain to you what this number means. Is 623 and the many zeros ahead. Let's say 20 zeros. How big that is? It's quite a big number, students. The meaning of 6.023 times 10 to the power 23 is this number. Very big number. All right, so in this case, we have how many zeros do we have? Let's just check. We have 1, 2, 3, 4, 5, 6, 7, 21 zeros. 1, 2, 3, 4, 5, 6. Okay, I think I should add another zero at the end. Zero here. That's how big this number is. So when you have this number of particles, this one, this is what is called a mole. That's a mole. So definition once again, make sure you know the definition of a mole. It's defined as the amount. By the way, mole is the amount of substance which contains this much. Due to typing issues, this is supposed to be 6.023, not 22, it's 23, times 10 to the power 23. This is 23, not 22, like this, the way it's written. You forgive me for that. I'm sorry, guys. Welcome, learners. What question number is this? 3, I think. Magnesium, we don't know how much this magnesium is. Let's just put a question mark there. And 20 grams of chlorine are available for the reaction, for this reaction. But we don't know yet how much magnesium this is. We're only told about the amount of chlorine, 20 grams. So the question is saying determine the limiting reagent. There's a lot of doing when it comes to limiting a reagent. By the way, a limiting reagent is a substance which is in small amount. Let's go back to the equation. So the equation here is supposed to be MgCl. Here must be Cl2. Remember that chlorine is diatomic. So the question we have here before us, I want you to listen and listen properly. Determine limiting reagent. Limiting a reagent, the two reagents we have here reacting are magnesium and the chlorine. So of these two, which are the limiting reagent, but also remember that we are only given 20 grams of chlorine, but we don't know yet how much magnesium was involved in this reaction. So nonetheless, we need to do a little bit of calculation. We need to calculate the number of moles in chlorine. How many moles are 200 grams? So we should convert the 20 grams. I said, let's say 200, forgive me. I said 20 grams. How many grams, how many moles are 20 grams? So we shall change the 20 grams of chlorine to moles basing on the equation here. How many moles are 20 grams of chlorine? That's how you start. You take the given mass, change it to moles. And you know that chlorine, Cl2, each chlorine is 35.5. That means two of them is going to be 35 times 2. So the moles, find moles of chlorine. So the molar mass of chlorine is 71. 71 is obtained because if you go back to the periodic table, each chlorine has 35.5. 35.5 times 1 times 2 is 71. All right, so this has a mass of 71 grams. But the number of moles is going to be the mass given divided the molar mass. 20 divided by 71 is 0.28 moles of chlorine. Take note, learners. So you compare this amount of moles. If you go back to the equation once again, there's one more here reacting with one more of chlorine. That's the ratio of 1 to 1. That means this number of moles is the same as the number of moles in magnesium. That means we need the magnesium. We need, in order for this reaction to happen fully, we shall need even 0.28, and in addition to whatever mass of magnesium we are given. All right, so that means magnesium is in excess, and therefore the limiting reagent is chlorine. If you haven't got that right, don't hesitate to come back. Don't hesitate to come back and ask. All right, so what is the mass of magnesium chloride? Based on the equation here, what is the mass of the magnesium chloride? So in order to do that, it needs to be understood that the molar mass of magnesium chloride using the values given here, magnesium is 24, chlorine is 35 times 2 is 70, so 24 plus 24 plus 24 plus 71 is 95. But we said that the number of moles for chlorine and magnesium was the same because magnesium and chlorine are combining in the ratio of 1 to 1. So in this case, the mass is going to be 95 times 0.28, which is 26.8. Welcome, learners. Number 4D, how much water must be added to 5 cubic centimeters of 6.0 molar of hydrochloric acid to dilute the acid to 0.1 molar. These numbers may need to make sense. What's 5.5 cubic centimeters? This is the volume of hydrochloric acid. So we already have a certain volume there of HCl. I want to give you a picture. Let's suppose we have this, and then we have five. Supposing that we have 5, so this is 5 mils or cubic centimeters. Remember that mils and cubic centimeters are the same. All right, of HCl. This is hydrochloric acid. HCl. That's what we have. Eh? And it has a concentration of, let's call this HC1, and this is V1, the volume, the initial volume, V1. I want you to understand this very well. Concentration of 6. 6 molar. Okay? This is volume. This is the volume. This is the concentration. So we are asked to work out how much water we can add here. Put there. How much water to be added? How much water do you need to add? How much water? Suppose this is water. Let's say this is water. How much water should we add? Volume. Let's call this volume. Volume of water to add. To produce a solution, this solution to have a concentration of to produce a new concentration. Call it M2. Sorry, C2 or M2, it doesn't matter. M is for molality. Let's call this C2 to produce a concentration of the whole solution after adding water of 0.1 molar. That's the situation we have. Students, want to find this volume here. Whatever this volume is going to be, we must bear on your mind that there's going to be a total volume of the whole solution. So to find the volume of the water, we must get the total volume of the solution. We subtract the given volume, the initial volume. Welcome, learners. My name is Mr. Pochilola once again. This is a very long lesson. It's almost 1 hour. Now we're into the 52 seconds, minutes. All right, so we use the dilution formula. You do recall from Form 3 chemistry, the dilution formula says C1 times V1 is equal to C2 times V2. In this case, C1 is the initial concentration. C1 is the initial concentration, and V1 is the final volume, the initial volume, the given volumes, concentration here, volume there. While C2 is the final concentration, and V2 is the final volume after dilution, meaning that the water added plus the 5 cubic centimeters together is the final volume. So what you need to do now is to substitute, apply the formula by substituting. So C1, which is the initial volume concentration, is 6. The initial volume is 5. This is equal to the initial final concentration 0.1 times final volume. This one here. Welcome, learners. Once again, I beg your pardon. This is a mistake. So we have V2. Solving for V2 will be equal to 30. All right, let's just do this. I think there's something that I've lost. All right, so in this case, rewriting the equation, C1 equals to V1, C1 V1 is equal to C2 V2, for which C1 is 6, V1 is 5, C2 with 0.1 times V2, final volume. And remember that this final volume is the total volume, the volume of the solution initially, which is 5, plus the added water. All right, so V2 in this case will be equal to 6 times 5 is 30. So divide both sides by 0.1. Yeah, so better now. So in this case, It means that the final volume is 3,300, sorry. So the 300 is coming because we are dividing 30 by 0.1, that's 300. So final velocity, sorry, final volume. The volume after adding water is this one. Welcome, learners. My name is your teacher. My name is Paul Chirora once again. Forget about this. So the final volume is this one. But this includes the added water and the first volume. So the water added, therefore, is going to be the final volume, 300 minus the given volume, which is 295. In case you have questions, don't forget to call me. I'm going to be available for you. Once again, my name is Mr. Paul Chilora. Subscribe to the channel. Invite your friends to join us. All right? Invite your friends to join us. Welcome, learners. So the volume to be added is 295. All right, number 5. Sorry for the break. Table 2 shows results obtained in an experiment to investigate reactivity of 3 metals. We are not told what these metals are in the expressed way, but we can assume that the metals are A, B, and C. All right, so it's found that when metal A reacts with the ions of the compound B2 plus, reaction happens. So for the reaction to happen between these two, it means A would be more reactive than B. So A could have displaced the ions of B. And when C reacts with B2, a reaction does not happen, implying that B2 is less reactive than C. So we are asked to complete this when A reacts with C, which is less reactive than B. What is it that we are going to have? So the reaction would imply that there will be reaction. Listen once again. When A reacts with, is combined with B2 plus, a reaction occurs. This means that A is more reactive than B2 plus. And when but C reacts with B2 plus, there's no reaction. This means is that C is not more reactive than B. No reaction. In other words, the ions of C cannot displace those of B2 plus. But when A, which is more reactive than B, reacts with C, there's going to be a reaction because A is more reactive than C. Therefore, there you were supposed to have said that here that a reaction is going to happen. Five B, write down overall reaction equation for the reaction of A and B. We said that A is more reactive than B and the reaction occurs. This means that A is more reactive than B. So when A reacts with B, it means they'll swap. A is going to displace B from its compound. So this is the reaction that's going to happen. And we have two substances, elements that we need to arrange in order for reactivity. We just mentioned that A is more reactive than B and B is more reactive than C. So the order is going to be in this order. A is more reactive than B and B is more reactive than C. Describe the steps you can follow to identify weak acid from a strong acid using universal indicator. But wait a minute. Remember, weak acid does not dissociate fully in solution. All right. And a strong acid dissociates fully in a solution. All right, so the question is assuming that you already know the difference. The examiner knows that is assuming that you already know the difference between these two. So how can you distinguish them, or rather to identify them? How can you tell a weak acid? And how can you tell that an acid is strong? Using a universal indicator. Remember, a universal indicator helps you to identify if a compound is an acid or a base, or strong or weak acid based on pH. Yeah, so how can you show that this substance is weak acid and the other one is strong acid? So the steps for max: take equal molar concentrations of suspected acids, two acids. You can take 0.1 of hydrochloric acid, which is strong acid by theory, and 0.1 molar, which is acetic acid by theory again, is weak acid. You can take any of the strong acid and weak acid that you know. All right. To each of these, you dip universal indicator paper into each of them, or add a few drops of universal indicator. Okay, can either use paper or a solution, then observe color change. Remember, 4 marks. Observe color change. When you observe color change, you would know that a solution is strong acid because of color. It will produce a red color. Red color corresponds to a pH of 1 to 2. You would know that it's a weak acid if it produces orange or yellow color with the pH of 3 to 5. Here we can rule out the chances of purple, pink, blue, and the like, because we are not dealing with bases. So these acids are within the color range of red to yellow. The stronger the acid, the lower the pH. So the weaker acid, the higher the pH. This is what theory tells us. 4 marks. Explain briefly how you could identify 3 compounds: ethanol, ethanoic acid, and cyclohexane, using a test. But before we proceed to the question, 5 marks, you need to understand what these are. So ethanol is basically an alkanal, which is also called ethanol is an alkanal, which is also called the aldehyde. I want you to get this right before we proceed. So this is alkanal. This is an acid, carboxylic acid. This is what you must know beforehand, before you proceed. And this is an alkane. And remember that alkanes are saturated hydrocarbons. meaning that they don't contain a double bond. All right, so proceed by starting with one of them at a time. Start with ethanol. How can you confirm that it's ethanol? A substance is ethanol. How do you confirm that something is an ethanol or aldehyde? All right, so to confirm that a substance is ethanol, you will carry out a number of tests. The test you would carry out is to use what is called Torrance reagent. Taurine is also known as ammoniacal silver nitrate, ammoniacal silver nitrate. But alternatively, you can also use Fehling solution. There are two reagents you can use. It's up to you. You can use taurine or you can use Fehlings. All right, so when you add a few drops of taurine, if the substance is the ethanol, which is aldehyde, it's going to form a silver mirror on the test tube. That tells you that the substance is ethanol. If it doesn't, then it's something else. But Fehling solution would form a red precipitate, which is copper, peroxide of copper. Then that would also tell you that it's ethanol, which is an aldehyde. These are positive tests. So a positive test would confirm these, would show these ones, these two things. If it doesn't, then it's another thing. Make sure you understand these things. So you have 2 marks for saying this. All right. Propanol, propanoic acid, which is a carboxylic acid, all right, has acidic behavior like other acids. So the test you to carry out is to add sodium carbonate, which is a base, or sodium hydrogen carbonate, which is a soda. So when you add these, if it is truly propanoic acid, which is like an acid, like any other acid, assuming that it's the only acid, then you are going to have effervescence. Effervescence is when a chemical reaction is giving bubbles or gas. So where effervescence is appearing, then it may mean that carbon dioxide is being formed. So when you see bubbles coming out, then indeed it's an acid. But here the condition is, we already know what acid it is. It's carboxylic. Because you can also get similar results with any other acid. Finally, saturated hydrocarbon, which is cyclohexane. In this case, you would use bromine. So add bromine and shake. If the color of the bromine in water changes from brown to colorless, it means it's what do you call this? It's an alkene. But if there's no color change, it means that it's something else, which can be an alkane. So no declaration, it means that declaration, it means that it's an alkane without double bond. If it is decolorized, then it's an alkene with a double bond. Welcome, learners. We still continue subscribing. Rather, welcome to number 6. Name one compound that contains dative bond. Dative bond. Did you know that the word dative, it comes from the word date, like dating? Suppose you have fallen in love with someone. That means you are dating, right? You are dating. Like X, if you are girl X, and you are going out with boy Y. The two of you are dating. You're in a date. And when let's suppose the man who is the one who proposed that you should be dating, you want to meet on a date. You have agreed to go to a hotel or any other room to meet the two of you. The man is the one to pay all the bills there. Pay for meals, pay for room. Sorry, don't do that. I'm just giving you an analogy for you to understand the origin of the word or the term dative. So the man is the one to pay all the bills there. But when it comes to bonding, it is one atom giving all the bonding electrons to another. Just like a man or a woman who pays all the bills for a date, dative. You must understand that. Of course, many people don't know where this came from. So examples of substances that have additives, that contain additive bond, ammonia, you have water, you have many others. I mean, not water no, but what is called the hydronium ion. Yeah, the one with the formula H3O plus. That's also dative. Welcome, learners. So if you mention the hydronium here, or now we have mentioned ammonium, the question B is saying illustrate the dative bond using the compound mentioned here. Okay, so B depends on A. If you said hydronium ion here, that means we will have to illustrate hydronium or ion here. But I've chosen us to use ammonium ion. So ammonium is NH4 plus. So we're going to use that to show the diagram here to illustrate the bonding in ammonium. And I'll leave the hydronium ion to you to use to show how it can be illustrated. Welcome, learners. So this is called ammonium ion. This one here, NH4 plus. Well, this one here is ammonia, NH3. Ammonia forming ammonium. Ammonia gains a proton, a hydrogen from something else. It could be acid-base reaction. All right, ammonia is a base. It will gain a hydrogen from an acid. It's going to form this. So before we get this, I want to explain a point here. If you look at ammonia, ammonia is purely bonded to 3 hydrogen atoms, purely. I'm using purely because this is just pure covalent bonding. But when you react with ammonia with something else, let's say an acid, the acid would donate a hydrogen ion only. Remember that acids are proton donors. So it will donate this donor, this hydrogen. That hydrogen is going to move all the way to come here. And by the way, hydrogen ion does not have an electron to share with something else in bonding. So it will just come here, over there, and bond itself to ammonia. This has no electron to contribute to the bonding exercise. So the lone pair, the two electrons known as lone pair on the ammonia are the ones that are going to bond with the hydrogen. Just like a man who proposes to date a girl would pay all the bills. Bedroom bills, bills, hotel bills, or lodge bills, whatever. Meals, will pay all the meals, and then when they're done, they'll go home. So here, it's ammonia which will contribute the two electrons to bond with this proton guy, like this. As you see, these two electrons from ammonia, from nitrogen, are being used to bond with hydrogen. End of story there. That's what this question is asking us. C. State Le Chatelier's principle. Although the syllabus, the MSCE syllabus, does not really emphasize on Le Chatelier's principle at all. The syllabus does not really dwell on Le Chatelier's principle. I think it doesn't really do that. But since it appeared in the question here, we are going to state the Le Chatelier's principle. So Le Chatelier's principle, named after Chatelier himself, is French law. The Chatelier, the law means the. The Chatelier principle states that. Understand that the syllabus does not really dwell on this for us to talk about it, but I'm sure the examiner was using a textbook. Using a textbook, and from the textbook, he or she came up with this question. So Le Chatelier's principle states that if a system at equilibrium, in reference to chemical reaction, that if a chemical reaction is at equilibrium, such a reaction is being disturbed by a change in concentration, temperature, or pressure. The equilibrium will shake itself. It will shake itself in order to bring back the original equilibrium, the new equilibrium. That's the meaning of this. When we say that a chemical reaction is in equilibrium, what it means, understand, is that the rate of the reaction in one direction, like a left forward reaction, is equal to the rate at which the products are recombining to form the reactants that formed the product. So that if we change the concentration of the reactant or the temperature of the reaction or pressure thereof, then there's going to be a shift. You may end up having more products forming or less products forming, and the reactants, more reactants forming backwards, and anything like that. That's what the Chatelier says. Once again, you may not have to bother yourself to understand Chattelier's principle much, because Chattelier's principle is not emphasized in the syllabus unless you are doing advanced level chemistry. Welcome, learners. My name is Mr. Paul Chirola, your teacher on this program. The two factors that affect equilibrium. Equilibrium is when the forward reaction is equal to the rate of forward reaction is equal to the rate of backward reaction. That's equilibrium. So how can that be changed? That can be changed by a number of factors, namely the concentration of the reactants. If the concentration is high, it means that we shall have more products than reactants. And it also follows temperature. If we raise the temperature, then the rate of the reaction is going to increase, which can either favor the forward reaction, where more products are forming, or a backward reaction, where the products are recombining to produce the reactants. And then pressure, which applies only to gaseous products, like this one, what do you call it? The Born-Haber process. The Haber process is a reaction which involves gases. You have nitrogen reacting with nitrogen gas, reacting with hydrogen gas, both of them gases, to produce another gas called ammonia. All right, so if we want to produce more ammonia, we just have to increase the pressure on the reactants, so we shall have more ammonia forming. Welcome, learners. E. The following is a reaction at equilibrium. So we have chlorate ion reacting with hydrogen ions to produce a chlorate ion, a dichlorate ion actually, and water. Basing on this, what effect will on equilibrium? What effect will be on equilibrium if aqueous potassium hydroxide is added? If we add potassium hydroxide here, hydroxide is OH, has OH in it. What are we doing? It means we are adding to hydrogen to form more water. So the effect that's going to have is that it will reduce the concentration of the OH, so the equilibrium is going to shift to the left, because the OH in the potassium hydroxide is going to react with water. I mean the H, it will form water, more water. All right? So this will cause the reaction to shift to the left. All right? So according to Le Chatelier's principle, removing hydrogen ions causes the system to oppose the change by producing more hydrogen ions, shifting the reaction to the left. If few drops of sulfuric acid are added, we are adding sulfuric acid to this. What does that mean? It means we are adding hydrogen ions. All right, so adding hydrogen ions, it means we shift this to the right, because more hydrogen ions will react with that to form the product. Welcome, learners. My name is Mr. Paul Chirola. You pardon me because I'm going to a bit fast. We already have hit 1 hour 30 minutes revising this paper. This paper is very worthy and very rich from Michiru view. The science teacher there, the chemistry teacher to be specific, asked many questions in 2023 just to give the learners, the students, ample practice. If you can hear me and you're from Michiru View Secondary School, please give kudos to the teacher who prepared this paper, because many aspects of chemistry are being addressed with the aid of a with the aid of an equation, explain how acid rain is formed. Acid rain. Remember, acid rain is formed in the atmosphere. When water reacts with some species in the atmosphere, the species would lead to formation of acid rain, which has got catastrophic effects on the environment. All right, so we shall use two examples here of sulfur and the nitrogen, leading to formation of acid rain. For marks, acid rain is formed when oxides of sulfur and nitrogen dissolve in rainwater to produce acids. We shall dwell on sulfur, then later on the acids. 2 marks for each. So in the first place, using sulfur would react with oxygen to form sulfur dioxide. The sulfur dioxide produced here in the first step will also react with more oxygen. This is further oxidation to produce sulfur trioxide. The trioxide of sulfur would react with water. With this water is rainwater, it will form an acid called sulfuric acid in the atmosphere, leading to formation of rainwater. So one form of rainwater is sulfuric acid. Another one involves nitrogen. Nitrogen will react with oxygen to produce nitrogen oxide. The nitrogen oxide will react with more oxygen to form nitrogen dioxide. The nitrogen dioxide will react with water and more oxygen to form nitric acid. These two will lead to formation of acid rain. 4 marks. The emphasis is the two equations for the first one and the two equations for the second one. That's 2 plus 2 make 4 marks. Welcome, learners. My name is Mr. Paul Chilola, your teacher. Please subscribe to the channel. Invite your friends to subscribe to this channel. It is important. Do that. My name is Mr. Pochilola once again. This is Black Slides Online Secondary School, the only platform that publicly teaches to give you review. Welcome to question number 7. Question number 7. All right, question number 7 is simply asking us to describe an experiment that could be done to identify whether dissolving ammonium chloride and sodium hydroxide is exothermic reaction or an endothermic reaction. Sodium hydroxide and ammonium chloride to show whether it's exothermic. So the examiner is already assuming that you know what exothermic reaction is. You also know what endothermic reaction is. Exothermic reaction is one that releases heat energy to the surroundings. The opposite. Endothermic reaction is one that absorbs heat from the surroundings into the reaction itself. So to show this, first you measure initial temperature, record the starting temperature of water in separate beakers before adding the solids. This is called initial temperature. Then you add ammonium chloride. This one is NH4Cl in water, and stir the mixture. Note the temperature change. At the back of your mind, you should know that you already have initial temperature there. So upon adding the ammonium chloride, you also measure the temperature. Then you repeat the experiment by adding sodium hydroxide. Dissolve sodium hydroxide in water and stir. Record the temperature. So these are two separate experiments. already you have 4 marks. So you compare the results. The temperature drop. If the temperature drops, the initial temperature drops, indicates that the reaction is endothermic. If the temperature rises, then the temperature is exothermic. So you expect this ammonium chloride to be endothermic. It will get the temperature decreasing. Actually, if you hold this test tube or beaker, you'll feel cold, meaning temperature is dropping. If you dip a thermometer into such a reaction, you'll see the temperature value range developing down. It means that the reaction is endothermic. So ammonium chloride is going to be an endothermic process, but sodium hydroxide will produce more heat and there's going to be a temperature rise. So that's exothermic. Using water molecule as an example, describe how a hydrogen bonding is formed. Remember that a hydrogen bonding exists between a hydrogen itself and a more electronegative atom. All right, so we are asked to explain how the hydrogen bond exists. Right, welcome back, learners. Sorry for that silence. So oxygen, you need to understand that oxygen is slightly negative. Oxygen is slightly negative. And oxygen is slightly negative. When you draw an oxygen atom like that, it has a negative charge. It has a negative charge of the magnitude of -2. Oxygen has a charge on it represented by that. It's negative. All right, so oxygen is slightly negative. We're explaining how a hydrogen bond is formed. But the hydrogen is slightly positive. So hydrogen is slightly positive, represented by a hydrogen atom and this partial charge, this symbol. Very, very important to note. Learners, welcome. So oxygen is slightly negative, hydrogen is slightly positive. So the positive hydrogen is pulled towards negative oxygen of another molecule. So another molecule which has oxygen will pull the hydrogen. All right? And the hydrogen donates oxygen's lone pair accept, meaning that the hydrogen is pulled towards the oxygen's lone pair. The pair of electrons that are not bonded, lone pairs, they are called lone pair. hydrogen donates its electrons, and the oxygen would actually accept the donated electron. So the molecules now link together through these attractions. So you have a molecule, let's say water, for example. One water molecule. Let's suppose we have a water molecule. Remember, water molecule is partially negative and has hydrogen, which are partly positive. Welcome, learners. Two hydrogen atoms, H2O. All right, so back to the explanation. We are saying that a positive hydrogen is pulled towards a negative oxygen of another molecule. Let's say we have another molecule here. We are looking at water for now. But water is not the only compound with hydrogen bonding. These things are called partial charges. Right, so the positive hydrogen is pulled towards a negative oxygen. This is what's happening. This positive hydrogen is pulled to this molecule. So there is some kind of attraction. There is an attraction between these two molecules. So this, I want to show you. Welcome. There's going to be an attraction of this hydrogen there. So this bond is an attraction which is called hydrogen bond. It's a hydrogen bond. That's how a hydrogen bonding is formed. Welcome, learners, once again. So the attractions are called hydrogen bond. Okay, 5 marks, 5 marks. So these 5 points, if written down properly, and you have also shown the diagram properly, you'll get 5 marks. Explain how branch isomerism affects the physical properties of an organic compound. I hope you understand what is isomers or isomerism. Isomerism is the tendency of a compound to form different structures of the same substance. You can have, for example, pentane, which is normal pentane, with a straight chain forming other pentane molecules with branches. So how does the branching affect the physical properties like boiling point, melting point, density, and the others? How? So whenever there is a branch existing on a chain, that would reduce a surface area. All right, it would also reduce the what? The size of the molecule. So we are saying branch isomerism lowers boiling point, which is basically a physical property, and melting point compared to straight chain isomers. The reason is because, so by saying there is one mark, because branching reduces how closely molecules can pack together. When the molecules are branched, they occupy a smaller area. This is going to weaken intermolecular forces. So because the intermolecular forces are weakened, it means that the physical properties such as boiling and the melting points, density, viscosity, and many others are going to reduce. 3 marks. So the 3 marks are resulting from the fact that we have mentioned 3 marks. Boiling and melting points compared to straight chains are going to be lower at 1 mark. Why? Because branching reduces how closely molecules can pack together, 1, and reducing intermolecular forces, another 1. 3 marks. Welcome, learners. Beg your pardon. So that's what you do. 6. With the aid of well-labeled diagram, describe laboratory preparation of nitric acid. Remember, you can prepare nitric acid in the lab. But you can also prepare nitric acid in the industry by what is called the Oswald process. We'll not describe the Oswald process now. We are going to describe the Oswald process later in the other lessons. But you should recall that the Oswald process was also taught fully by us, and the videos uploaded on the channel. They just say, go to our channel, Black Slides Online Secondary School, look at the Oswald process. Then you shall find the Oswald process there. For now, we are going to look at the preparation of nitric acid using the lab, in the lab. So the diagram you do need is this one. You do have sulfuric acid, concentrated one, and being added to potassium nitrate, also sodium nitrate. The issue here, we need the nitrate part. All right, then heat the mixture. Okay, so this is the delivery tube, which you deliver gaseous nitric acid, and then it's cooled by cold water there, and the nitric acid is collected there. You need to be careful because some of these are very highly corrosive substances. Welcome, learners. So this is a diagram, label diagram. The minimum number of labels is 3. The diagram is worth 1 mark, and then the labels are also 1 mark. So you have 2 marks. Anyway, some markers, examiners will give labels 2 marks, and the diagram 1 mark. Welcome, learners. My name is Mr. Paul Chilola, your teacher. Teacher by choice, not by chance. All right, so this is the diagram. Remember the diagrams in the MSc exams are given marks. Then you narrate your story here. Usually a question that says you must use a diagram will give you space for the diagram and then lines for you to narrate your story. So use nitrate salt. For example, you can use potassium nitrate, you can use sodium nitrate, all right, as a source of the nitrate part. Nitrate. and the sulfuric acid, concentrated sulfuric acid, conc, right? Having done that, you show the displacement equation in which the nitrate is displaced by the hydrogen in the reaction here. So that is going to produce nitric acid, which is going to rise up and be delivered down here in gaseous form. And then when the water is introduced, cold water, there is going to be condensation here, which forms nitric acid over there. So the heat is the mixture is heated gently, and then we have the product being collected on the other hand. Then condense the vapor and obtain nitric acid in the condenser. Welcome, Lawrence. Yes, but hello. Libeno. Sigo. Kifundo. Ndio utamene. Ndio uti. Sino moziwa. Oh, okay. Mafuna ndani. Mufuna ndani ino. Ino mufuna ndani. Ai namba isi ya chifundo iya. Sigo. Ai need to. I South Africa, yeah. Ziko mwambi. Ziko mwa bye bye. Sure. So with the diagram properly shown, you should be able to get all the 6 marks. I'm sorry for that disturbance, because not that important anyway. Question number 9. Describe with the aid of an equation the decomposition of calcium carbonate representing an irreversible reaction. A reversible reaction is one which does not go backwards. That's it, 3 marks. All right, so when calcium carbonate, CaCO3, is heated strongly, it breaks down into calcium oxide and carbon dioxide. All right, according to the equation. Remember, the question is saying with the aid of an equation. So the equation is over here. Calcium carbonate is being heated to produce calcium oxide and the carbon dioxide. So the carbon dioxide will evaporate. Will go into the air. The carbon dioxide is going to escape into the atmosphere, preventing the reverse reaction. So the decomposition is irreversible under normal conditions. So what we are saying is this carbon dioxide will go. So the carbon oxide will be the only product remaining in the reaction vessel. So there's nothing that can combine with carbon oxide to form back carbonate. Therefore, it is a reverse process. Very, very important. Explain briefly the preparation of oxygen in the lab. under a catalyst. And remember, a catalyst is a substance that speeds up a chemical reaction. All right, so we are called upon to explain how oxygen is formed using a catalyst. So you take hydrogen peroxide as a source of oxygen, H2O2, as a starting chemical. Once you take that, you add manganese oxide or manganese dioxide, which speeds up a chemical breakdown of hydrogen peroxide. So the hydrogen peroxide is going to break down according to this equation. All right. So hydrogen peroxide and the manganese dioxide as the catalyst will produce water and oxygen. So it is the oxygen which we need in this process. The oxygen gas is released, collected over water in a gas jar or cylinder. 4 marks for these 4 points. Welcome, learners. Explain how ethanol is prepared by hydration of ethene. Remember, alcohol ethanol can be produced by fermentation and by hydration of ethene. All right, so ethene is reacted with steam under controlled industrial conditions. Then a phosphoric acid is used as a catalyst at a temperature of 300 degrees Celsius and 60 to 70 atmospheric conditions. These are the conditions. As a result of that, ethanol, C2H5OH, is produced. Take note. So this is the reaction that will take place. Describe how the hydronium ion is formed. I mentioned earlier on when we were looking at the ammonium ion. So how is the hydronium formed? Remember, hydronium ion is a substance that executes additive bonding. So in order to form hydronium ion, a water molecule, H2O, which has a lone pair of electrons on the oxygen atom, is going to react with an acid. So when an acid dissolves in water, it releases it releases hydrogen ions. So the lone pair of on oxygen attracts and bonds to the H, forming the hydronium ion. 3 marks. Welcome, learners. Explain any two differences between polar and nonpolar covalent compounds. A polar covalent compounds has an equal sharing of electrons due to differences in electronegativity, for example, in hydrogen chloride, while a nonpolar covalent compound has equal sharing for electrons, for example, chlorine. 2 marks. Question number 10, I believe we are coming to an end. Describe it to show the electrolysis of dilute sulfuric acid is the same as electrolysis of water. I'm sure this is how far I intended to go. All right. So pure water is basically a poor conductor. So dilute sulfuric acid is added only to produce ions that carry current. When you add this sulfuric acid, which is an electrolyte, to water, you have an electrolyte that can conduct electricity. All right, so hydrogen ions gain electrons at the cathode to form hydrogen gas. And in the process, according to this reaction, hydrogen ions in the solution will gain 2 hydrogen ions to produce a gas called hydrogen. So hydrogen ions from the water lose electrons at the anode to form oxygen gas. So I've been fast. This lesson was supposed to be for 1 hour, but it has gone up to 2 hours. All right. Then the OH is going to gain oxygen to form water. The OH is going to be oxidized into oxygen and water. So hydrogen is collected at the cathode and oxygen at the anode in the ratio of 2 to 1. As a result, since the products are identical to those from water electrolysis, which is oxygen and hydrogen gas, we have oxygen here and hydrogen gas, then this simply means that we are basically electrolyzing sulfuric acid.